Hey everyone, this is Mr. Stumbaugh. I'm going to be walking you through these first few days of lessons. I'm going to try and keep these videos short and sweet. Hopefully you were in class. And I know myself, Mr. Bledsoe, and Miss Warchow do things a little bit different. So if you see something different, be sure to ask your teacher exactly what they want. So you should be here on Dell City Math YouTube. Hopefully you were able to kind of find the Algebra 2 playlist or folder, however it's going to set up. We first talked about combining like terms, adding and subtracting polynomials, but it's combining like terms. They have to have the same variable with the same exponent. So 3x and 5x, like that, they can combine. Now what we don't do is we don't mess with the x's at all. The x's are just there to help us group them together. Think of it as a last name. Same last names go together. And what I was telling my kids, if we're doing like 3 bananas plus 5 bananas, we get 8 bananas. We don't get 8 bananas squared or 8 banana or anything crazy like that. So we're really just messing with the coefficients, which are just the numbers in front. The powers do not change. When you see subtraction, like this guy right here, there's an invisible one right here we'll talk about in a minute that gets distributed to everything. Really all you got to do is take the x squared, the 2x, and the minus 3, and change the signs like we do right here. Once we do that, our x squared, sorry, that's our x cubed. I don't have another x cubed over here, so it's just going to stay as x cubed. If it doesn't have anything to combine with, don't combine it. It's not a big deal. Sorry about that. Where we left off, 3x cubed. I don't have any other x cubes. So now I look at my x squared. I got 1 here and 1 here. They're underlined in red. -2 and a -1. Same signs, add and keep. It becomes -3. X squared stays exactly as it is. X to the first power, 1 subtract 2 was a -1, invisible 1 right there. And this 3 didn't have another constant to go with it, and it just does that. Okay. So here, x squared and x squared, group them up, add them together. X and x, group them up, add together. Constant and constant, group them up, add them together. And again, once you group them up, don't make this x to the 4th or x squared here or trying to add anything there. That just helps you group it up. After that, I really only care about the numbers in front. Same thing here. We'll distribute. And I apologize, should have distributed to all of them. You see 4 became -4, -2, +2, +1, -1. Once we do that, then we've taken care of this. X squared and x squared, group them, add them together. X and x, group them, add them together. See what I had, I think I had that there for a reason, because I have a lot of people that just go here and just make this negative. And so this part's right, but then they leave this as a -2, and then all of a sudden you have a wrong answer here. And then you'll have a wrong answer here. Also, make sure it distributes to everything. I want to talk about our understood ones. Our understood ones are the invisible ones that are there but are never written. So every time you see x by itself, most of y'all can think, oh, that's 1x. What you may not remember is every variable with an invisible exponent has an exponent of 1. So back here, we would write x squared, but there's invisible ones right here that we don't write. And then if you ever need a fraction, dividing by 1, and if you think about it, multiplying by 1, dividing by 1, and with an exponent of 1, it doesn't change the number at all. It just changes kind of what you may need for that particular situation. Here's some more distributing. Just remember, when you have variable times variable, you really just add the exponents together. So x to the 3rd times x to the 7th is x to the 10th. So when you do x times x squared, 1 plus 2 becomes 3. And so all you got to do is multiply big numbers and then add exponents every time. So 3 times the invisible 1 is a 3. X and x squared become that. Multiply here, 3 times invisible 1 is 3, x and x is x squared, 3 times -2 is -6, x, and There's no x right there, so we just leave it as this is the only x that's there. Foiling should be somewhat familiar. A lot of y'all do the moon method. Foiling stands for first, outside, inside, last. So you do your first terms here, the first two terms. Then you do the outside terms, the one on the outsides. Then you do the inside terms here and here. Then you do the last terms of each one. And when you do that, you get this, and then you know we're going to combine like terms because these both are x to the first power. We get our answer. I was showing my kids the box method. This is kind of like doing DNA in biology, where you take one term here and one term there, and you just got to fill in all the boxes by multiplying. I like this method because it kind of keeps everything a little more organized. Your like terms are usually catty-corner from each other, and you still get the same answer. It's still 8 minus 21. 8 and negative 21 become negative 13. You still get the same answer. Box method works great when you go a little bit bigger. So I can do the moon method here. It gets kind of crazy. But when you do the box method, remember x and x squared times x is x to the third. X and x is x squared with the 2. And there's our like terms again, kind of catty-corner for each other. In this case, 2 minus 2 became 0. 4 minus 4 became 0. What I don't want is just you to write, oh, well, 2 minus 2. Well, I still need the x squared here, and think of an invisible 1 in there. In fact, those are not there at all. I do not want the x squared and the x because they are zeros in front of it. So either one of these green answers is okay with me. Just understand that on a test, it'll look more like this. So that's the end of today. I'll do a separate video for the next day.